in the last case study for this unit, we are going to see how to predict if you have dependent data, and in fact this dependence forms time series. It is in the context of sunspot numbers. So sunspot numbers are something which was discovered by Wolfer in Middle Ages. In fact, there are spots on the surface of Sun, and the number of these dark spots changes from year to year. And it looks like that this change of number of sunspot numbers is periodic. And they found that every 10 to 11 years, we have the cycle for these sunspot numbers. So the data that we got are yearly data from year 1770 to year 1869. And data are averaged over months. So we need to predict the mean number of sunspots for year 1870. Of course, we know, and it was 139.1 averaged over months for that year. The model that we are going to use is classical model for time series. It is autoregressive of order 1 model. What is autoregressive of order 1 model? Let me briefly say a couple words about it. The number of sunspot numbers at time t would be regressed with some slope phi to the number of sunspot numbers at time t minus 1. And some random innovation, z of t, some white noise, I wouldn't say error, but some innovation, random, is added. So this is called autoregressive because you regress the observations at time t to observations from the history. And the order of the autoregressive process, in this case 1, tells you how far in the past you go. Here we go just 1 year back. So let's take a look how the first data look like. We got n equals to 100, and for these 100 years, we have the number of sunspots averaged over months. And we say that all of them have the mean y bar. Then we demean the data because notice there is no intercept here. So I'm going to look at the data y of t minus y bar, and that's my x of t. I would say that x of t is normal with mean m of t and some precision tau. And if I want t is between 1 and n, I may want really to connect this t with the year, actual year, when these sunspot numbers are observed. So this is actual year. Not for first year, but from second year, we can say that m of t is phi times x of t minus 1. And z of t to be added would be this x of t which was measured, which was counted, minus m of t. So this really puts the model to be x of t is equal to phi x of t minus 1 plus z of t. But what happens in year 1? In year 1, you don't have the history. You don't have x0. For that one, you have x1 minus z1, and z1 you construct. You put some prior on z1. You cannot find z1 this way, and you construct z1, and you get m1 as x1 minus z1. Also, if I plug in the xn to this model, and phi is going to be found, and add x bar, I will predict the number of sunspot numbers for year n. So this would be to predict for next year. The rest of the model is involving putting the prior on phi, which is non-informative, putting the prior on the precision, which is also non-informative. And we run this program. The data we saw already, data initials are phi is equal to 0, sigma is equal to 10, and then we got the monthly numbers. What is the prediction? Well, prediction is you go to the node tool from the info, and you get that prediction is about 70. We'll see that this is not a very good prediction because that year for which we predicted number as 70, it was more than 100 sunspot numbers. So here we go. These are the means over the years. This is prediction. This is estimator of phi less than 1 here. And then we, using the inference menu, found comparison tool. Here we look at the plot of m, which is the mean of these sunspot numbers. X's are years. These are actual years, and we got really actual years. And x is other, so these x's are the values, points. In this graph, you see how the fit looks like. It is periodic. The dots are the observed sunspot numbers, the mean is subtracted, and you see periodicity here, and the periodicity is every 10, 11 years. And you see how the model, given in red, but then there are two lines, blue lines, which are 95% credible sets around the model. So even though the model is very simple, autoregressive with one step back, it captures the behavior quite well. The prediction in this kind of models shrinks toward the mean. So this predicted value is shrunk toward the mean. For better prediction, we would probably need more elaborate model, not autoregressive one.